Greetings, my friend. I welcome you all in the zero lecture of reinforced cement concrete design. The course code is CIV331. So in this course, we are going to design the different structural members such as foundation, column, beam, slab, staircase. In the design, we will learn that how the different kinds of load such as dead load and live load acts on a structure, what is the after effects of those loads, and with respect to those loads how movement will act, and with respect to those movements how reinforcements will be provided in different shapes at different orientations. In this course, we will learn to understand the basic performance of concrete and steel as structural materials, and the behavior of reinforced concrete members and structures. If we understand the basic concepts of codal provisions for design, we will be able to approach the design in more knowledgeable fashion and understand the changes in code provisions better and faster. The overall goal is to able to design reinforced concrete structures that are safe, economical, and efficient. Reinforced concrete is one of the principal building materials used in engineered structures because low cost, weathering and fire resistance, good compressive strength, formability, all these criteria make concrete an attractive material for wide range of structural applications such as buildings, dams, reservoirs, and tanks. So the basic content which we will deal with in this subject is design of RCC beam, in which both singly reinforced beam and doubly reinforced beam we will study. Also, shear, bond and torsion are the extended topics which will ensure that the design beam is safe or not. In design of slab, one-way slab and two-way slab topics we will cover. Design of staircase, majorly with the straight flight and dog-leg staircase design we will learn in this course. In design of columns, the different type of columns we will study, and in design of foundation, different type of foundations and their shapes, how to do design, that we will learn. If we talk about the course detail, the LTP of this course is 220, which means there are going to be 2 lectures and 2 tutorials in this course. The basic textbook which you can follow is Reinforced Concrete Limit State Design by Ashok Kumar. There are other references book available too, which is Design of Reinforced Concrete Structure by N. Subramaniam and RCC Design by Dr. B.C. Punamiya. There is an IS code which will help us to provide different codal provisions with the reference of which we will be able to design different structural members. The IS code which we will use in this course is IS 456-2000. CA category of this course is going to be 3 out of 3, which means all the 3 components are compulsory, out of which 2 components are going to be academic task test and 1 component will be design problem. So this was the basic detail of this course. Now I'm going to show you a video which will help you to understand that with which orientation we provide the structural elements, what are the parts and the type of reinforcements which provide the tension capacity, which increase the tension capacity of the different structural members such as foundation, column, beam and slab. And this video will give you a basic idea that how all the structural elements are constructed altogether.
Site
So let's
preparation
begin.
consists of clearing away the trees from your building site. This involves the removal of trees, roots, and other vegetation from the building site. After cleaning the site plot, marking of plot should be done as per drawings. Excavation. A structural engineer will be needed to determine the depth of the excavation. The depth will vary as per building depending upon soil strata. Excavation should be carried out as per the drawings defined lengths and widths. Excavation is to be done by the JCB. PCC. After the excavation, the surface is leveled. PCC poured over leveled surface. Foundation shuttering. Shuttering arrangement for foundation is to be made. Once PCC is done, shuttering for foundation is placed. It should be strong enough to withstand all types of dead and live loads. Foundation bars. Foundation bars shall be laid on the surface. Main bars and distribution bars shall place as per drawing. Column bars. Proper arrangement to be made for column bars with links as per drawings. Column steel and foundation steel to be tied properly to avoid joint cracks. Reinforcement shall be as per bar bending schedule prepared according to drawing. The reinforcement shifting and binding shall be started as soon as shuttering is completed. Reinforcement binding shall continue as shuttering work progresses. Concrete work and foundation. A foundation is a poured concrete pathway that is used to spread the weight of the building from the foundation to the soil. It is very necessary to check the levels of foundation before concrete work. Depth of foundation varies from 1.5 to 2 meters. Shuttering removal. The formwork removal procedure should be supervised by the engineer to ensure that quality of hardened concrete and structural member. That is, it should be free from or has minimum casting defects such as honeycombing, size and shape defects, etc. These defects in concrete influence the strength and stability of structure, thus immediate repair works can be done or the members can be rejected. Backfilling. Once the foundation is completed, backfill the remaining excavated area around foundation with soil. Backfill provides stability to the building. A Euro trademark S foundation. Beam reinforcement shall be as per drawings. Top bars, bottom bars and stirrups to be placed with proper development length. Joints in the beam shuttering should be tight against leakage of cement grout. Construction of shuttering should permit removal of various parts in desired sequences without damage to the concrete. Beam concreting. Beam is poured with concrete with grade mentioned in the drawings. The positioning of reinforcement should be properly aligned. Shuttering parts and connections should be arranged in a way that makes formwork removal easy and simple, prevents damage to concrete and formwork panels so that it can be reused without extensive repair. Slab concreting. Grade slab requires no reinforcement as it's resting on ground strata itself. Top of plinth beams and grade slab should be at the same level. Column shuttering. Column shuttering should be rigidly constructed and efficiently propped and braced both horizontally and vertically, so as to retain its shape. The shuttering should be set accurately to the desired line and levels should have plane surface. Column concreting. After the concreting of footing is complete, immediately in a day or two starters for columns should be casted with proper alignment. Columns are very important members in RCC design. Wrong placing of column may affect the overall behavior of structure. Concreting of RCC columns should start from the center of vertical bars and go towards the ends. Column shuttering removal. Shuttering should not be removed until the concrete has developed sufficiently strength to support all loads placed upon it. The separation of forms should not be done by forcing. It may damage the hardened concrete. Beam reinforcement. Beam reinforcement shall be as per drawings. Slab reinforcement. Slab reinforcement shall be as per drawings. Main bars and distribution bars shall be placed as per design. Slab reinforcement should be properly anchored with beam bars. Slab shuttering. Beam bottom is first laid on the column and then slab shuttering is laid. Beam. Beam and slab levels should be maintained as per drawing. Slab concreting. After the concreting of column, beam and slab concreting shall start monolithically. The top of floor beam and slab shall be maintained as per levels. Slab shuttering removal. Special attention is required for